Hey everybody, welcome back to chemistry. And so what I want to do is some problem solving related to energy. And to do that, I need to sort of get you accustomed to the units we use to describe energy. So if I can increase the slide, I want to explain the units of energy here. And so one of the basic units we use to describe energy is something called the calorie. So I have it here, and it's defined as the amount of energy needed to warm up 1 gram of water up 1 degree Celsius. But very importantly, we have to be careful when we're talking about a calorie. And the reason is this. There are actually two kinds of calories. The one I just mentioned is one kind. Again, this is the calorie that one of it will heat up 1 gram of water by 1 degree Celsius. And so this kind of unit of energy is called the scientific calorie. And the way we identify a scientific calorie is we use the abbreviation CAL, but I want you to notice here that the C here is a little c. Now that brings up, there is a second kind of calorie. So the second kind of calorie is also called the calorie. The second kind of calorie is not a scientific calorie. Instead, this is a dietary calorie. And the way we distinguish the dietary calorie from the scientific calorie is we write out the abbreviation of calorie for the dietary calorie with a capital C. So you have to remember, if you're seeing the word calorie or the abbreviation with a small c, that is a scientific calorie. If on the other hand, if you see the word calorie or the abbreviation with a capital C, we're talking about a dietary calorie. And so you're probably very familiar with dietary calories. If you look at a nutrition label on the back of a piece of food, it will usually tell you the amount of dietary calories that are in one serving of that food. And so we can see that this piece of food here on the right has 230 dietary calories per serving. But you have to remember, if it has 230 dietary calories, then it has a certain number of scientific calories. And in fact, one of the conversions you need to know is that there are 1,000 scientific calories and 1 dietary calorie. So going back to this here, if you have 230 dietary calories, you have that times 1,000, which gives you 230,000 scientific calories. And then there's one more conversion you need to know about when we're talking about units of energy, is that 1 scientific calorie is equal to a certain number of something called joules. That is another unit of energy which you sort of have to get used to. Chemists nowadays tend to like to talk about energy in terms of joules, but say before 1980 was mostly talked about in terms of calories. So what I would like to do is move on to some problem solving. So let me first call out the first problem that says, how many scientific calories and dietary calories are found in a Hershey's Kiss, which contains 9.2 times 10 to the 4 joules of energy? So if I can reduce the slide. Okay. So what I want to do is I want to take 9.2 times 10 to the 4 joules of energy, and I want to convert this to both scientific calories, and then also I want to convert this to dietary calories. And so again, to distinguish between these two calories, note I wrote scientific calories with a little c, and I wrote dietary calories with a big C. And so let me show you how you're going about doing this. And so the first step is to take this joules and get it into scientific calories, because we do know of a conversion between joules and scientific calories. So this conversion will be given to you on the test, which is that 1 scientific calorie, so it's small CAL, is equal to 4.184 joules. So I think what you can see here is with one step, you can get 9.2 times 10 to the 4 joules into scientific calories, which will be a little c. But then we also want dietary calories. So how do we do that? Well, what you have to do is you have to know the conversion between scientific calories and dietary calories. And they're what you'll probably have to know for the test is that there are 1,000 scientific calories, little CAL, in one dietary calorie, capital CAL. And so from that conversion, you should be able to get any kind of scientific calories into dietary calories. And so let me go ahead and solve the problem. So we have 9.2 times 10 to the 4 joules. First, we're going to get this into scientific calories. So we have an equality here. 1 scientific calorie is equal to 4.184 joules. I'm hoping that in your mind, you can think of the two fractions that you could possibly write to help you solve the problem. But the one we want is the one where we get joules here to cancel out with a fraction that has joules in the denominator. And in the numerator, we have calories, scientific calories. So I'm going to write here 1 scientific calorie over 4.184 joules. And so let's see where we're at this point. Joules cancels out, and so the math would be 9.2 times 10 to the 4 times 1 divided by 4.184 joules. That should give us the number of scientific calories in 9.2 times 10 to the 4 joules. But what we want to do is also find out how many dietary calories there are in 9.2 times 10 to the 4 joules. And so what we can do now, once we're in scientific calories, we can easily convert this to dietary calories using this conversion. And so again, I'm hoping you can, in your mind, sort of imagine the two fractions you can make with 1,000 scientific calories or in 1 dietary calorie. And so what we want is the fraction where the scientific calories here, the numerator cancels out with scientific calories in the denominator in the fraction you want to use. And then dietary calories is in the numerator. So what do we want here? So what we want is, it looks like 1 dietary calorie, so it's capital CAL, over 1,000 scientific calories. Anyway, so if you do this math, I think what you'll find is you'll see that scientific calories cancels out, dietary calories does not cancel out, and if you do the numbers, it's going to be 9.2 times 10 to the 4 times 1 times 1 divided by 4.184 divided by 1,000. And so you should get 22 dietary calories. So now that you know 1 Hershey's Kiss has 22 dietary calories, okay? So let me erase the board and we'll do the second problem. If I can increase the slide. So let me read out the problem. It says a Snickers bar, which has a mass of 44 grams, has 215 dietary calories. Convert this to kilojoules per gram Snickers bar. Okay, so if I can reduce the slide. So this is a little bit trickier. So what we're told is that a Snicker bar have 215 calories, dietary calories, right? And essentially what we have to do is convert this into sort of a very unusual units that you may not see very often. The units are kilojoules, so it's little k, capital J for joules, but it's weirder. It's kilojoules per gram. Okay, so what do you do? All right, so you can see we're right now at dietary calories, and I think you can see eventually we want to maybe get this into joules, because then we convert joules to kilojoules, reminding ourselves that there are 1,000 joules in 1 kilojoule. So the question is, how do we take dietary calories and get this into joules? And so I don't know of a direct conversion of dietary calories to joules, but what I can do is I can take dietary calories, get this into scientific calories, and then I can get that into joules with the conversion we know, which is 1 scientific calories equal to 4.184 joules. Then we can get that into kilojoules, and I'll show you a trick to get that into kilojoules per gram. Okay, so here we go. So here we're starting out with 215 dietary calories. Let's get this into scientific calories. And so I'm kind of hoping you know at this point, we want 1 dietary calorie here in the denominator and 1,000 scientific calories, so little CAL, in the numerator. So far so good. And so what you can see is that the dietary calories cancel out, and we have scientific calories. And so now let's get this into joules. So let me go ahead and put 1 scientific calorie here in the denominator, 4.184 joules in the numerator. And you can see at this point that the scientific calories cancels out, and now we're in joules. And so that brings up, how do we take joules and get this into kilojoules? Well, I'm hoping that you might be able to figure out that the prefix kilo means you have 1,000 of something. So if you have 1 kilojoule, you have 1,000 joules. And so here, what we might want to do is put 1 kilojoule here over 1,000 joules. Okay, and so let's see where we're at now. And you can see joules cancels out and kilojoules is left, right? But here's the thing. That's not enough. We want an answer in kilojoules per gram. So what do? So there are a number of ways you can solve this problem. Let me show you how you can get kilojoules into kilojoules per gram using dimensional analysis. I'm going to show you a trick which you often don't see. So you'll notice that you have a Snickers bar, and you're told that that Snickers bar is 44 grams. And so here we have the total number of kilojoules in that Snickers bar, right, which is 44 grams. But what you can do to get it in kilojoules per gram, you can put that number of grams here in the denominator like this, 44 grams. And so you might be wondering, well, in dimensional analysis, do I necessarily have to have some kind of number or unit in the numerator? And believe it or not, in dimensional analysis, the answer is no. You don't necessarily have to have that. So you are welcome to divide by 44 grams. And so if you want to make sure that you're dividing just by 44 grams, what you do here, you don't want, again, you don't want a number here, and you don't want a unit in this position here. So we put a 1 here. And so again, in dimensional analysis, you're allowed to do that. And so now you can see that the units, because kilojoules doesn't cancel out, that will be in the numerator, and grams does not cancel out, that'll be in the denominator. So the answer will be in kilojoules per gram. And so the math would be 215 times 1,000 times 4.184 times 1 times 1, divided by 1, divided by 1, divided by 1,000, divided by 44. And I think if you work that out and round to correct number of significant figures, your answer should be 20 kilojoules per gram. This 20 here having 2 significant figures, so I'm putting a decimal point there. Okay, well, thank you for listening. We'll see you next time.